Guys, welcome to the class. In this lecture, we are going to discuss about pile driving equipments, what are the different types of pile driving equipments, and batching, mixing, and placing of the concrete. What are the different equipments we have for pile driving? Uh, Pile driving rigs, which are of three types: skid mounted, crane mounted, and also floating rigs. Guide leaders, pile driving hammers, additional aids for pre-boring, jetting, etc. And boilers for steam raising or air compressor. Wow. How does these pile driving equipments helpful? Pile is a structural member driven into the ground for the purpose of transferring surface loads. Here, pile is a structural member which is driven into the ground for the purpose of transferring surface loads. So all these equipments we have here, which are helpful in uh, pile to be driven into the ground. So pile driven rigs. How these driving rigs provide basic operation of lifting the pile, holding the pile in the position, and hammering into the ground or pulling it out. So, uh, these pile driving rigs provide the basic and essential operations of for the pile which has to be lifted or fitted into that hole to hold into its position or also hammer this pile into the ground. So here these pile driven rigs helps to provide guiding of the pile in the desired direction of the movement. It also supports the boom, the winch and mechanism to be driving the hammer, the guiding leaders and the platform for mounting the auxiliary equipment such as jet pumps, drilling, auger, etc. So this is the skid mounted rigs. Here you can see these are like the tripod arrangement here, three legs has been provided and a drilling can be seen here. So the pile can be driven into the ground or to be supported on the ground and which are in the desired direction of the movement. This is the skid mounted rig, skid mounted rig, and here the crane mounted rig. All these equipments, all these rigs plays a major role in the driving of the pile into the ground. Crane mounted rigs. Here there is an hydraulic pile hammer. Here you can see this is the hydraulic pile hammer which helps uh, an additional force to apply on that an additional mechanical force to be applied on the pile which helps in driving the pile into the ground. Here this is the top sheave and this is the supporters for this crane lifted rig. Here this is the supporter and the pile which is to be driven here with the help of a hydraulic pile hammer. Here also you can observe this is the hydraulic hammer. These are the floating rigs. Here the pile can be driven with the help of a additional outward mechanical force which is applied on the pile. Guiding leaders. These leaders guide the pile and the hammer during the operation, which extends to the entire height of the rig. In case pile driven below the rigs into excavations or trenches, the extensible leaders are used. It enables hammer to deliver blow axially to pile. These are the guiding pile leaders here. You can observe these can support these guiding. leaders can support the pile to be driven here. These are the leaders for the support which helps the pile to be driven to the ground surface by an additional mechanism. These are the guiding leaders. The types of hammers we have are drop hammer, single acting hammer, and double acting hammer. So here in this drop hammer, no external source to be needed. So a mechanism to lift the hammer by a cable here. This is the hammer which has to be lifted by the cable and drops it. This cable can be released and the weight of the hammer itself with the help of gravity drop onto the pile so that the pile can be can be driven into the ground surfaces. So the solid mass of metal or cast iron is weighed about 1 to 4 tons. The height of the fall is of 1.5 to 6 meters. So the number of blows per minute it can have or of about 4 to 8 blows. Depends upon the height which we lifted based on the height of the hammer which we lifted by the help of cable. So the number of blows can be 4 to 8 per minute. It is a slow process but an efficient one to drive the pile into the ground, and it is not in use in nowadays. So the single acting hammer. Here the hammer is lifted by steam or compressed air, and it also can be dropped by the gravity. The weight of the hammer is of 2 tons. The height of the fall of this hammer is of 1 meter, and a number of blows, a 60 number of blows per minute can be blown by this uh, single acting hammer. And here the double acting hammer. The hammer is lifted and lowered by steam or compressed air, and the weight of this hammer is of 500 kgs, and the effect will be like 3 tons. The number of blows it can blow per minute are 100 to 200. Differential acting hammer. The hammer is modified form of double acting hammer which weighs about 2 tons. The height of fall is 1 meter. The number of blows it can blow per minute are 100 to 200. The same pile can be driven within half time, saving 30% of the steam. Diesel hammer. Here, the hammer imparts compression, impact, and explosion energy to the pile. We can see the working principle of these, uh, the rise of the piston to start here by using the mechanical, by using the hydraulic. Here, the pile can be lifted. So, the injection of diesel fuel and compression. Here, fuel injection can be seen, and then the rise of the piston can be started. And also when we push the button, these these piston which is raised due to the hydraulic, so the piston can be released and which can be departed and impact and gives explosion to the below pile to be driven into the ground. These are the diesel hammers, which exhausts ports exposed and gases escape here. These are the ports provided for escaping of gases, any voids present in these uh, diesel here draws fresh air through the exhaust ports and push the uh, exhausted, exposed, and gases escape from these voids. The vibratory hammer, a very effective in driving piles through non-cohesive granular soils. The pile is driven by making vibrations. The vibrations which are then produced by electrically or hydraulically. The penetration rates can approach up to 20 meters per minute. In moderately dense granular soils, it can be used with another methods also. Here, these vibratory hammers, which are very effective to driving the piles into the ground through a non-cohesive granular size. So, next, batching, mixing, and placing of concrete. Here, the proportionating the ingredients of concrete for a particular mix. Wave batching is commonly used for proportionating the ingredients. Here in the concrete, we have different types of materials combined together: cement, coarse aggregate, fine aggregate, and water. Uh, to mix these ingredients, the element of water is used, and the proportionating of these ingredients with the help of wave batching is commonly used. The manual batching and semi-automatic batching and automatic batching. The concrete batchers. The concrete mixers mix all the ingredients of concrete to make a mix of specified consistency. The factors governing the mixing are correct setting of machine, proper cleaning of blades, the sequence of material charged, timely supply of water, the direction of inflow, and speed and timing of the mixing. The types we have are drum type mixers, tilting and non-tilting mixers, the pan type mixers. So the factors which govern the mixing are when we the process of mixing has been completed, the proper cleaning of blades should be done for the next batch, so that there is un there is a un available of waste materials which are presented, which are stick onto the blades, can be removed. So the proper cleaning of the blades to be done before the next amount of batch has been produced. So the correct setting of machine can be done without any delays. So the timely supply of water into the mixer is also helpful